Hi students, the second half of 9.5 is about using and completing the square, which we learned yesterday, to rewrite quadratic equations so that they're in vertex form. You'll be going from standard form to vertex form. Last chapter you went from vertex form to standard form. My kids are here and they want to say hi. Say hi, Leo.
Hi.
Say hi, Isla.
Hi.
All right. We're going to start the lesson. Okay. So just a reminder, our goal is to make our quadratic look like it's in vertex form. And vertex form is the one that looks like a times x minus h squared plus k, so that you can easily see what the vertex is. Right now it's in standard form, and so we're going to use completing the square to get there. First thing we're going to do is move the constant, just like we did when we had this equal to 0. It's not equal to 0 anymore, but we're still going to start by moving the constant. So we're going to move 11 to the other side of the equation. On the left-hand side of the equation, we get x squared minus 8x. We got rid of the 11. On the right-hand side. On the left-hand side, y and 11 are not like terms. So we write those next to each other. We write y minus 11. We can't combine them because they're not like terms. Okay, the next thing we're going to do is we're going to complete the square. When we complete the square, just because we have an equation, we need to make sure that we add our constant to both sides of the equation. So I'm going to go ahead and draw my square. My square has an x squared in the corner, and it has negative 8x, but because it's a perfect square, those have to be divided equally. So this would be negative 4x, and this would be negative 4x, so that together they make negative 8x. So then that means that this dimension would have to be x by x in order to make an x squared box, and this would have to be negative 4 in order to make a negative 4x box, and so would this, because it's a square, and then this corner would be negative 4 times negative 4, which is 16. That's the number we're going to use to complete the square. So we're going to add 16 to both sides of our equation. If we add something to one side of the equation, we have to make sure to add it to the other, otherwise our equation is no longer true. Now we're going to rewrite our stuff, so we're going to combine our constant. Negative 11 plus 16, those are like terms, so we can add them and we get 5. And then on the other side we have x squared minus 8x plus 16. But we've already done the work. We know that that's x minus 4 squared. So we're going to rewrite that so that it looks like x minus 4 squared. That's the factored form. They're both the same. Both factors are the same, so we can write squared instead of writing each factor separately. The last step is we're going to move the new constant back. I called it the new constant because before it was an 11. Now it's a 5. We're going to subtract 5 from both sides. And we get, on the left-hand side, we get y. And on the other side, we have something that looks a lot like vertex form. It'd be x minus 4 squared, and then minus 5, because that's not a like term. Okay, that means that the vertex is at 4, because we always change the x coordinate, comma, negative 5. We know a lot about this quadratic right now. We know its vertex. We know its y-intercept is 11, because we know what it looks like when it's in standard form. We know that a is 1, which means it opens up and it's the same width as the parent function. All right, these are 2 for you to try. I want to make sure that you pause the video before you go through my solutions. So please make sure you pause at this point and then come back after you've tried each problem. Okay, the first thing you do is you subtract the constant to the other side of the equation. So I subtracted 3. And then I looked at my x squared minus 2x, and I want that to be a perfect square. So that means I need to share the 2 into 2 boxes. That's why that's negative 1. We always divide by 2. And then the outsides of that box would be x and negative 1, x and negative 1, and negative 1 times negative 1 would be positive 1, which means this time we're going to add 1 to both sides. So then we have y minus 2 is equal to, and the factored form is x minus 1 squared. the last step is we're going to add 2 to both sides. So we get y equals x minus 1 squared plus 2. Make sure you've tried the other one before you continue the video.
The first thing we're going to do is subtract 25 from each side of this equation.
Then we're going to complete the square with x squared plus 6x. When we complete the square, we find that the constant we need to add in order to make it a perfect square is 9.
So we add 9 to both sides of the equation. Mom, what about...
Leo wants me to tell you that he's too sick to help. That's why Isla's doing all the helping.
Now we add 16 to both sides of the equation.
And we get y equals x plus 3 squared plus 16. That means that the vertex for this equation is negative 3, 16. The y-intercept was 25 because we could see that when it was in standard form. I forgot to say what the vertex of the first one was. The vertex of the first one is positive 1, 2. Remember, we always change the sign on the x-coordinate, but we don't change the sign on the y-coordinate. Right. In this example, we have a parabola that has an a term. That's why this is an upside-down parabola. It would be narrow, except I think that the scale of the graph makes it not look very narrow. I don't know if you know this, but they use this type of motion in an airplane so that the passengers in the airplane can experience zero gravity and experience what it's like to be in space. So the airplane follows this flight path, and then the passengers can see what it's like to float around in space. So the question we're trying to answer is, what is the maximum altitude reached by the plane? We're trying to figure out the highest a value. So we're trying to figure out the vertex of that graph. Okay. So the equation we have is a equals negative 5t squared plus 80t plus 9,000. Okay, just like last time, the first thing we're going to do is we're going to subtract 9,000 from both sides of the equation. A and 9,000 are not like terms, so we subtract and just write it down. And here's the part that's different. Now, it's not just an x squared, so what we do first is we factor out the GCF. Both of these terms can have a negative 5 factored out of them, so I'm going to use that as the GCF. Remember, that makes it look like before you distributed. So that would be t squared, and then 80 divided by 5, but divided by negative 5, would be negative 16t. You can totally use a calculator for this. You don't have to do this in your head. The left-hand side of the equation is a minus 9,000. Now, when we complete the square, we're going to be looking at what's inside the parentheses only. So we'll write that square down. It's going to be t squared. And then the negative 16 we want to be evenly divided, so that would be negative 8t and negative 8t. We always divide by 2 for completing the square. And then the outsides of our box would be t minus 8 and t minus 8. And that means that this missing part, the square, would be 64. So that means to complete the square inside of these parentheses, I need to add 64. But since I'm adding 64 inside of the parentheses, I'm not going to add 64 to the other side of the equation. I'm actually going to add negative 5 times 64. So this side of the equation, I'm going to add negative 5 times 64. Because if I distribute the negative 5, I'm not just adding 64, I'm adding whatever I do. Okay, Leo. So now it's going to be Leo's turn to help us out. We have a minus 9,000, and you guys can grab a calculator, but I have Leo here, so he's going to tell me what negative 5 times 64 is.
Negative 320.
All right, so this will be negative 320, and then we're going to rewrite this, and then we're going to do negative 5, And we'll write this as the outsides of the box because we've already done the work of figuring out what that is in factored form. So that'll be t minus 8 squared. And then we have, if we combine these like terms, we have negative 9,320 equals negative 5 times t minus 8 squared. And Isla's going to tell us how to get the negative 9,320 to the other side of the equation.
Add it to both sides of the equation.
All right, we're adding it to both sides of the equation. 9,320 on both sides of the equation so that it's still an equation. And we get a is equal to negative 5 times t minus 8 squared plus 9,320. The question asked, what is the maximum altitude reached by the plane? That means we want the y-coordinate of the vertex, so the maximum altitude is 9,320, and the altitude is measured in meters, so we have 9,320 meters. And then the amount of time it takes to get to that maximum altitude would be the time, the x-coordinate of the vertex, which is positive 8 seconds. It's kind of handy that negative 8 seconds wouldn't make any sense for this equation, for this situation. Okay, now I want you to pause the video and I want you to try this process. Again, this is a time when you would have a calculator so that you're not trying to deal with these big numbers without a machine or without a super math brain.
Like me.
Like Leo. All right. I'll pause now, you pause, and work out this problem on your own.
4 subtract 705 105 from both sides of the equation.
Thanks, Isla. Next, you want to factor the 7 out of the right-hand side of the equation. It's a GCF. So when we do 7x squared divided by 7, we get 7. And when we do 168 divided by 7, we get 24x. Okay, the next thing we're going to do is complete the square. So we have x squared, and the 24 needs to be evenly distributed, so we're going to make that 12x and 12x. And then this missing part of the square is 144, which means we're going to add 144 to both sides of the equation, but not really because we're inside the parentheses here. So really we're adding 7 times 144 to both sides of the equation. That's the difference when you have this extra step here. And you're going to feel free to grab a calculator, but I have Leo here, so I have y minus 105. And then what's 7 times 144?
7.
7 times 144 is?
Okay, the answer is 24. For the...
Yep, the division problem was 24. What was the answer when we multiplied?
Okay. The answer is 1008.
Okay, so I'm going to add 1008 here. And then on the other side, I have a perfect square, so I'm going to write that. So I have 7 times x plus 12 squared. And then I'm going to combine my like terms here. So I have y plus 903. And we're going to move the 903 to the other side. So we're going to subtract 903 from both sides of my equation. And our final answer is y equals 7 times x plus 12 squared minus 903. And that means that the minimum value of the function, since this is an upward-facing parabola, the minimum value of the function is going to be the y-coordinate of the vertex, or negative 903. All right, that's your lesson for today. Please be kind to the sub, and I'll see you tomorrow. I'll see you on Friday, actually.